All right, we're going to go through it and try to do this really the way probably you'll want to do it very often. And we're going to just start using this calculator. I'll leave what I had in Excel up because we don't need the screen space anyway. You started your calculator, you're in second mode. You check your mode, second mode. Mode, everything looks good, degree. You probably want to get your float down there so you can see it. You don't get lost in there. Hit an enter, second quit. And now you have some points, so it's a great idea to put points in list 1, 2, and 3. That's probably the best place for them. Learning how to do it, not necessarily just by going into lists, by going ahead and using the format that's going to tie you to something else, like most other programs that deal with lists, where this is the standard format. So that, comma, at, you're going to store it into second list 1. Now you can take and put the second one, and so the second point is 25, comma 0, comma 8. Close up your list, store it into second list 2. Now you've got 2 lists stored. Once again, the squiggly defines a list. 0, comma 25, comma 8, close the squiggly, store it into second list 3. You now have list 1, list 2, list 3, and I guess point 4 we decided was, in this case, was 16.67, 16.67, and 4. That could have been determined by someone telling you the cable lengths and doing basically a 3 tape in 3D. So once again, 3 tape in 3D is just the intersection of 3 spheres, easily done with the right software, easily done in AutoCAD. So we're going to go ahead and once again, second squiggly, 16.67, comma 16.67, comma 4. You've defined your points, second squiggly, store it into second list 4. Non-real. Oh, made a mistake. Hit a clear here. Luckily, clear doesn't clear everything. We can go second squiggly. 16.67, comma 16.67, comma 4. Remember, the list 1s through 6 are great for graphing, so sometimes you're not using that for other stuff. But in this case, we're going to go ahead and store it into second list 4. Now you don't always have to keep all your information. So when you're doing this, you've got in list 1, you've got a point 1, list 2, point 2, list 3, point 3, list 4, point 4. And remember, of course, that a point is a vector. So you can now take point 1 minus point 4 and put it back into list 1. How do you do that? Second list 1 minus second list 4. Store it into second list 1. You now have list 1, which is cable A. You can take second list 2 minus second list 4, store it into second list 2. Remember, this is not a math statement, it is a programming statement. You're taking a variable, updating it with the new condition. And finally, second list 3 minus second list 4, store it, go back here, second list 4, store it into second list 3. You now have your 3 cables going up. List 1, 2, and 3. The next step is to normalize, if you would, normalize this vector. And so that's to take each vector and divide it by its length. How do you do that? Well, you take each vector and you divide it by its length. You can do second list 1 divided by second list, the sum of second list 1. I'm sorry, I want to go back here. You want to know the square root of the sum right, of second list 1 squared. In other words, you're going to square each part of that list and they're going to divide the list, and you're going to store that back into second list 1, and right there you have in list 1 now your unit lambda sub A. I'll do the rest not in record, but basically that's a great statement to put in a program because you'll be doing 3 lists a lot. But what you're doing is you're taking list 1 divided by the distance formula for list 1 written in a matrix format. Okay, now what we want to look at here, now that we have these both on the screen, we can check that these should be the same from system to system. There's the math, they're all correct. And so once again, first thing you do is you ask a machine a question you know the answer to. You might trust Excel, you might trust your calculator, you probably trust CAD. Make sure you get these systems down before you go whole hog. Right now, here's something to highlight. Remember a new matrix function that we haven't used before, which is to take these lists 1, 2, and 3, put them in a matrix, and then go ahead and transpose the matrix. So here's how you put a list of lists into a matrix, and that is second matrix. Going down through here, list to matrix, and then you just list the lists that you want. Second list 1, comma, second list 2, comma, second list 3, comma, and you end it with the matrix that you want to do, and we'll go ahead and put it, in this case, we'll put it in the matrix F. Close our parentheses, and you have matrix F. Now formed. You can look at it, second matrix F. Again, remember, however, this is not the transpose matrix that we need. This basically is the going across of going across the page here. We need to transpose it, so we actually describe the vector in stacks. Remember, this is describing one vector, this is the other, and this is the other, so we need to transpose. So how do you transpose? You use the matrix calculation. This one's a little different, however. You have to do second matrix, get your matrix first, and then use the math, second matrix, transpose, and I'm going to tend to tell you to put it, store it into a different one. You could store it back on top, but second matrix, we'll put it into G. And it did put it there. Now what you have is G, which you would like now to augment, if you would. Augment an extra column onto G. And so what you're going to do is you're going to make a matrix that's a 3 by 1 with your 0, 0, 10, and then you're going to augment G. And so here's how we can go about augmenting G. We're going to go ahead and go second matrix, and we'll find one that's not using. We'll see, let's say. We'll go there, and that's not the one we want to do. We're going to go second matrix. We're going to edit matrix C, and there's probably a better way to do this, but we're going to make it a 3 by 1, and remember 0, 0, 10. Right, so now we have matrix C. Second, quit. Here's how we augment matrix G. Second matrix, augment, second matrix G, comma, second matrix C. All we've done is we've kind of slapped one matrix on the side of the other. When we do that, we think we have what we need. Let's see if matrix G is updated, because I don't know that it is. Second matrix G. We needed to put it back into there. We wanted to do the augment and actually stick it back in G. Let's try that. Augment, second matrix G, comma, second matrix C, and now let's just see if it'll let us store it into second matrix G. Now this is some little extra punching that you're used to, but it is something to get used to. We hit that button there. We now have G, And of course, you know, all you've got to do now is hit that function RREF for G. So let's finish it out. Second matrix, math, RREF, second matrix G. Remember, it's that 4, 3 by 4, close parentheses, hit an enter. And there, we hope, is the same answer we got before, which it's not. So, we'll have to chase through these numbers and see where we blew in the transcriptions and the math, and we'll make comments, but I'm not going to recut this. Thanks for listening.